Do you share the same IP address? The short answer is yes. The longer answer is all your own computers share one internet address through that little box that you plug into your internet connection. And the guy who's stealing internet from you just jumps onto that box and goes out through the same path. So yes, they from the externally, which is why we said you get in trouble if they do something bad. It looks like it's all coming from you. Yes. Yeah. How fast would the connection between here and Mars be?
Now you got to think about the fact. Well, are they on this side of the sun or the other side of the sun?
The closest at the shortest distance, it's about 8 minutes, I think.
That's Mars?
Yeah, about 8 minutes at the shortest distance, but it can be much longer because Earth, this is the sun. Earth and Mars sometimes are on the same side of the sun, so you're pretty close. And sometimes Mars is over on the other side of the sun, and you're much further away. So it can actually range to, I don't know what the largest number is, but I think the closest is 8 minutes.
I think it's on the order of 30 minutes. I remember that from the page.
In watching the Apollo 13 movie, it seemed like the limitations that they had with the spacecraft then was power. You know, they kept on talking about you can't, get over somebody else. What's the limitation now? Is it power? Is it the time? Is it the placement? Is it computing? What is it?
It's mostly computing. You'd be surprised how old the hardware is that's flying in today's spacecraft. It's stuff that was in your lap, in your not even laptops, in your desktops like 20 years ago, 15 years ago. Why? Space is nasty. If we took his iPad up to the space station, it'd be dead in about a day. Radiation, all sorts of nasty stuff. You take it further, you take even a less sophisticated device out far beyond Earth, where there's some shielding around the Earth. You get outside that, stuff gets torn apart just by solar wind. So the biggest limitation right now is finding what are called radiation-hardened components. And so stuff is slow, expensive. So you're dealing with computers with a few, sometimes as little as a few megabytes, not gig, megabytes of storage. Not so good, not very fast. That's it. That's one of the big limitations now because you have to keep them alive, and that's hard.
Okay.
Yeah.
How many satellites does a signal have to usually go through to get to Mars?
How many steps does a signal have to go through to get to Mars? Right now, it is usually one. It's possible. One satellite could be one other hop. So little Wally may directly talk to the satellite that's orbiting Mars. It may also have to talk to its ground station. There was the thing it rolled out of is a little spacecraft that has a communications package in it. So it may talk to that first, and then that talks to the satellite that goes around Mars. Usually right now, the big NASA dishes, they have about 3 or 4 parts around the world, will talk directly to the satellite that's around Mars. Now, in the future, we're going to probably put a communication satellite sort of a third of the way, roughly, between here and Mars to make that easier, so it'll be an extra step to go through. Right? So right now it's one satellite, probably be 2 or 3 in the future when we really have a lot of spacecraft up there, which is a while. Oh, sorry. Yes.
Okay, so the question was, if you're watching somebody on a network and you're seeing that they're watching ESPN, is it possible to get into their machine and mess with the mouse and do all sorts of other evil things that are a lot of fun? And the answer to this is going to be, it depends. it's really kind of difficult to break into people's machines, to control the mouse and do things like that, just because normally if you're going to do that, you need to spend a lot of time trying to figure out the right way to do it, because you need to figure out a weakness in OS X or something like that to use to get in. But if you're talking about doing fun things like messing with the way the video looks or the way the pictures look, like for example if you wanted to add a mustache to, you know, like a little pen mustache to a picture of somebody on ESPN, then because that's going over the network, it's really easy to do that.
We'll flip the page upside down.
Or, for example, good point. Sam here brought up something. Remember we were talking about unsecured wireless stuff? Like somebody sets up an unsecured router? So somebody got really mad that, and this was a computer person, and so, you know, they're like, oh wow, I can't believe these people are stealing all my bandwidth. And so what they did is they set up their router to take all of the pictures that were coming in for websites and display them upside down. And so everybody who connected to this person's internet, who wasn't supposed to be there, got all of their images upside down. It was pretty cool. So, called it Upside Down Internet. Any other questions?
Along the same line, if you're looking at someone, maybe they're texting with each other like you were doing at the first, could you break in on that conversation as one of the people and respond as them, or no?
Repeat the question.
Okay, so the question is if if you see texts going across the network, like for example the Facebook messages we were monitoring earlier, is it possible to pretend to be the person that's sending the messages, or to create new messages that the other person didn't actually send? And the answer to that is a qualified yes. The yes comes, you can't actually send messages as other people, but just because, okay, you know, you're sending it unencrypted network, that kind of thing. But the qualification comes in is that you need to understand the protocol they're using well enough to do that. And the protocol itself needs to be unencrypted to the point, or you need to be able to break the encryption to the point that you're actually able to pretend to be somebody else that you're not. And does that make sense? Does that answer the question?
So can you do it?
I'm going to refuse to answer that question. Next question.
No, we did that as a class project in the spring. We hacked into...
Well, we did email.
Maybe.
Okay.
Well, okay, email is generally really, really easy to do that with. So, whereas Facebook is a little bit harder, and if you're talking about Skype, that's really, really, really difficult. So. Okay, so somebody brought up that maybe not everybody understands what a protocol is, so I guess I'll go on a little tangent here. So, when you're sending bits and bytes across a network, right, that access point up there in the ceiling is basically seeing all of these bits go by, right? And if you're just seeing a whole bunch of bits and they're all scrambled, it doesn't know who's sending what. And so the idea of a protocol is to put a little bit of organization in there, right? We add some order to all of this chaos, so that the access point can look at all the bits and make sense of them. So naturally, since different people are writing different applications, they're going to want the bits to be ordered differently. So like for example, Skype wants 1001 to come at the beginning of all of its messages, for example, and that's totally wrong, but that's just a contrived example, whereas AOL Instant Messenger might want 1101 or something, or they might want it at a certain position in the message. But the whole point of an internet protocol is basically organization, so that I can understand you. We're speaking the same language. So English to English, German to German, whatever. If I don't understand German, then I can't understand you, if you're speaking German.
Anybody else? Any other questions?
Well, then let's thank the speaker.